Okay, so let me go ahead and just get started here. Sorry to interrupt there with the way visit. I know you were talking about that. I'll talk with your cases about your case later. So first things first. If you did not collect your exam, your exam will be in my. I'll be getting your exams, and they'll be in my office today. So if you did not get your exam for some reason, you can come by. You can also come by and ask about corrections on your exam during office hours. Now, one thing I have to talk about with the TAs, there was one question that nobody got right. So that was the concatenate problem. Nobody got full credit on that one. So that one, I think I'll let students for their grade, since that seemed to be a bit unfair. If nobody got right, then I think that one, if you give me your correct answer, a correct answer on that, we will adjust your grade for that one. So we will bump your grade up for that problem, which was worth 7 points. So that and how long it would take. Now so that other than that, I don't think there really be a way to increase your grade on the exam. But if you think there was something that you were graded unfairly on, please come by me during my office hours or some other time. So that's with regards to the exam. Next, let's see. So I've been posting the recursion videos, right, since last week. For this lecture, I'm going to be assuming that you have watched the videos that went up to. I'm going to assume that you watched the videos that were up to that went up to part 2, right? So part 2 will cover the stuff that's on Wednesday, and then the stuff that said week 7/8. That's the stuff that basically is for the that's more pertinent to your homework for this week. Okay. So there will be an in-class exercise today as opposed to a quiz. Now for that one, that's going to be more of a participation grade. So if you turn in a correct answer, if you turn in a correct answer, and there should be no reason why you don't turn in a correct answer, you should be able to get full credit on this one. It's essentially a homework assignment that you need to upload, but it's under quizzes rather than assignments. So let's just go ahead and talk about the content that we've been going over for this chapter, which is recursion. Okay. Now let's just make sure. So recursion is this kind of powerful problem-solving technique we have, where basically we have some kind of method, right? And inside of the method, it calls itself, right? And the example that I went over, the prime example that I went over, where's that? The prime example that we go over is factorial. Although that's a lie, the prime example that's typically given is Fibonacci, which is what we're going to do as our in-class exercise today. But let's go over factorial. Fact of n, so calculating n factorial, right? What is n factorial? That's the n followed by the exclamation point, right? So that's n times n minus 1 times n minus 2 times n minus 3 and so on and so forth, right? All the way down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1, right? Should be familiar with you. You should watch that video. So, and there's this mathematical definition, right, for factorial. Projector view, okay, which is that n factorial is equal to 1 if n is equal to 0, and then otherwise, forget my mathematical notation, but it's equal to 1. Otherwise, it's equal to n times n minus 1 factorial, right? It's one of these two things. It's not. Okay, it's either equal to n times, it's equal to 1 if n is 0. Otherwise, it's n times n minus 1 factorial. Now, this is a recursive mathematical definition because what we have here is that we have n factorial over here, and on the other side we have n minus 1 factorial. Now what makes this work is that n minus 1 factorial, that will compute and calculate n minus 2 factorial, right? So for instance, we're trying to solve 5 factorial. That was 5 times 4 factorial. And so our question is, what is 4 factorial? Well, that is 4 times 3 factorial, and so on and so forth, until we get all the way down to 1, right, as I've broken down. And I broke that down in the lecture videos. So the way we code this up is we basically code up the base case. If n is equal to 0, right, as our base case, well, we just simply return the base case. Now remember, the base case is basically what we're saying is it's the version of the problem that's so simple we don't even have to do any thinking to solve it, right? 0 factorial is 1. Although that does prompt some thinking as to in the question of why, and the answer is I have no idea. I have no idea why 0 factorial is 1. But we know that's what it is. Otherwise, we return we execute the recursive case, which is return n times fact n minus 1. Now the reason this doesn't produce an infinite loop is, right, if we pass in 5, this will call 4, which will call 3, which will call 2, which will call 1, and 1 will call n is equal to 0, which will return 1, and so it will start a whole chain of returns up the call chain. Okay, now, so that's factorial. Now, that I said was, now that's the example I like to start with. Now, the first recursive function I learned was not this. Instead, the first recursive function I learned was Fibonacci, the Fibonacci sequence, which is as follows. So this is the first one I learned, and I don't teach it first because honestly, solving it recursively, and the goal of our in-class exercise is to see this, solving it recursively is terrible. It's not hard to write at all. It's actually beautiful and elegant to write. But as we're going to see, the runtime is terrible. Actually, it's abhorrent, abominable, abhorrently abominable. I can't stress how terrible the runtime is. So let's go ahead and just talk about what is the Fibonacci sequence. So the Fibonacci sequence starts off with 2 1s. The first 2 numbers of the Fibonacci sequence are 1 and 1. The next number is 2. The next number is 3. The next number is 5. What's the next number in the Fibonacci sequence? 8. So a lot of you are clued into what it was just simply because the Da Vinci Code was a thing. But does anybody want to tell me? But for those of you who aren't in the know on this, does anybody want to tell them how did we calculate the Fibonacci sequence? Yep, the next number is equal to the sum of the 2 previous numbers. So the next number is 13 because 5 plus 8 is equal to 13. The next number after that is 21 because 13 plus 8 is 21, and so on and so forth, right? 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, and so on and so forth. So now this is definitely a recursive sequence because to calculate the next number in the sequence, we rely on the previous numbers in the sequence. All right? So let's go ahead and write our mathematical definition for this, okay? For the Fibonacci sequence, right? Let's say the fib of n, and we're going to say that n is the nth Fibonacci number, okay? We're going to say n is the nth Fibonacci number here, okay? It's equal to 1 of 2. Well, that's a bit of a big curly brace, right? It's equal to 1 if n is equal to 1 or n equals 2. Honestly, we could say 0 and 1 over here, but it really just depends on who you're talking to. Some people say the Fibonacci sequence starts with a 0. Some people say it starts with 1, 1. Some people say, very few people say it starts with 1, 2. And some people say this is the 0th Fibonacci number. Some people say this is the first, right? Whatever. I'm going to say this is the first and this is the second, right? Right? Just for simplicity's sake. This is n is equal to 1, n is equal to 2, n is equal to 3. Just for simplicity's sake here. Okay? So you don't have to think about it too hard there. Okay? So that's our base case. right? Because I said this is how the Fibonacci sequence starts. The first two Fibonacci numbers are 1 and 1. Otherwise, it is fib of n minus 1 followed by, plus fib of n minus 2, right? This number is equal to this number plus this number, the previous two numbers. All right, so your task for right now is that I want you guys to take 5 to 7 minutes and code this up. This shouldn't take you too long to code. I've given you the recursive mathematical definition, so code this up. Right? This should be the instructions for this you can find in the quiz section under your assignments. Go to assignments, go to the quiz section, code it up. If you work with somebody on this, be sure to turn it in. Be sure to turn in your own copy later on, so that I know for a fact that you did that. Because each of you will need to turn in the copy so I can check it off. Then the next thing we're going to do after this is find out why I said this is such a horrible thing to do, why this is terrible. So go ahead and get started on this.